find the heat produced in an electric coil of resistance 45 ohms. So the resistance then is 45 ohms. When a current of 12 ampere flows through it for 20 minutes, time is 20 minutes. So checking the parameters here, we have the resistance in ohms, we have the current in ampere, then we have the time in minutes. So we need to change this minutes to seconds. That's the SI unit of time, and that will give us 20 multiplied by 60, and that is 1200 seconds. So for us to get the heat produced, there are three formulas you need to know regarding current electricity whenever you want to get the heat or whenever you want to get the energy produced. So number one, we have E to be IVT. Number two, we have E to be I squared RT. And the third one, we have E to be V squared over RT. So now, this E represents the energy, that's the heat energy. So now we have R, we have I, we have T here. So the best one we can go for is E equals to I squared RT. So going for this now, what is the current? The current is 12, that's 12 squared. The resistance is 45. And then we have the time to be 1200. So 12 squared will give us 144 multiplied by 45 multiplied by 1200. So this will give us 7,776,000. So to change this to standard form, we are going to have 1, 2, 3, 4, 5, 6. That will give us 7.776 times 10 raised to the power 6 joules. So this is the answer, 7.776 times 10 raised to the power 6 joules. And that should be option C. Option C is 7.78. So that means we have it in 2 decimal places. So changing this to 2 decimal places, we are going to have 7.78. So the right answer, like I said, that's option C. So next question. Which of the following is exclusive property of a transverse wave? So you need to know this, that all the waves actually undergo reflection, refraction, diffraction, as well as the interference. But when it has to do with polarization, only the transverse wave undergo polarization. So for the longitudinal wave, they do not undergo polarization. So here it says, which of the following is exclusive property of a transverse wave? That is polarization. So the next question, it says a metal rod of length of 2 meters. So the length of the metal rod is 2 meters. And a coefficient of linear expansivity. So this is the symbol. And it has its value to be 1.2 times 10 raised to the power minus 5 per Kelvin. If the temperature of the rod is increased by 56 degrees Celsius, so that is what we call the change in temperature, which is 56 degrees Celsius. So please, in this case, you don't need to change this to Kelvin. It's not necessary now. So in this case, you do not need to change this to Kelvin. Do not change 56 degrees Celsius to Kelvin. Leave it this way. What will be the new length of the rod? So we want to get the new length, and that is L2. So this represents L1, which is the original length. So for linear expansivity, we know that we are going to have it to be change in L over L1 change in temperature, where the change in L is L2 minus L1. But for you to easily get the value for L2, just know this, that L2 will give us L1 into bracket 1 plus. So you want to get the L2, that will give us L1 into bracket 1 plus the linear expansivity times the change in temperature. In case you want to do for A2, that is for the area now. So in terms of area now, we do not deal with linear expansivity, but we deal with the area expansivity, also known as the superficial expansivity. This is the symbol. We use beta to represent that. So if you want to get to know A2, so this will just give us A2 equals to A1 into bracket 1 plus. So since we are not dealing with linear expansivity, we are going to have it to be the beta now, then change in temperature. So for volume, we are going to have it to be V2 equals to V1 into bracket 1 plus. For the volume now, we are dealing with volume expansivity, and we use gamma to represent that. Then change in temperature. So now we want to get to know L2. So for L2, L1 is 2 meters. We have 1 plus. What is linear expansivity? That is 1.2 times 10 raised to minus 5. And then the change in temperature is 56. So this will give us 2 now into bracket 1 plus. So to easily do this now, you can change this one to ordinary form. And that will give us 0.000012, then multiply by 56. So this will give us 2, then we have 1 plus. So let's multiply this. This will give us 0.000672. So 1 plus this will give us 1.000672. So if we multiply this, we are going to have 2.001344 meters. So checking the option, the right answer there is 2.001 meters. That's option D. 2.001 meters. So we have the option in 3 decimal places. So changing this down to 3 decimal places, we are going to have 2.001 meters. So that is the answer. The next question says, which of the following unit is derived? So we want to get to know the one that is a derived unit. So we have Newton, we have meter, we have kilogram, and then we have Kelvin. So the right answer there is Newton. Newton stands for the unit for force, and force is known to be a derived quantity. So being known to be a derived quantity, then it's going to have its unit to be derived. So derived quantities, they have derived units, and fundamental quantities, they have fundamental units. So there's a video where I talked about fundamental quantities as well as derived quantities. So check the video, you can see on the screen, and do well to study. So another question says, the energy stored in an inductor of inductance. So we have the inductance, that's L to be 5 millihenry. When the current is 6 ampere. So we want to get the energy stored. So to get the energy, we have the inductor given to us. We also have the current. And we need to change this millihenry to Henry. Like I always say, know how to convert. Conversion of unit is very, very important. So this millihenry now needs to be changed to Henry. And this will give us 5 times 10 raised to power minus 3 Henry. That is divided by 1000. That's the meaning. So now to get the energy now is going to give us 1 over 2 Li squared. So this will give us 1 over 2. What's the value for L? L is 5 times 10 to the power of minus 3, then multiplied by I is, that's 6, so that's 6 all squared. So this is going to give us 1 over 2 multiplied by 5, multiplied by 10 to the power minus 3, then multiplied by 6 squared, that give us, so 6 squared will give us 36. So 2 here 1, 2 here, that is 18. So 18 multiplied by 5, that will give us 90. Then we have times 10 raised to the power minus 3 joules. So changing this now to standard form, this 90 we turn to 9 times 10 raised to the power 1. Then we now have times 10 raised to the power minus 3 joules. So 1 minus 3, that gives us minus 2. So we have 9 times 10 raised to the power minus 2 joules. So the correct answer there is option A, that's 9.0 times 10 raised to the power minus 2 joules.